So this video, I just watched an Ant-Man movie the other day, so I'm thinking about superheroes. We're reducing their power. Um, I don't know. There's so many superhero movies. I can't keep them straight anymore. I thought it was the second Ant-Man movie, but it was the third Ant-Man movie because it wasn't just Ant-Man and the Wasp. There was like a subscript. So it was like the second Ant-Man and the Wasp, but the third Ant-Man, but really like the fifth Ant-Man if you include other stuff. And I don't know, it's like the 50th Marvel movie. Can't keep it straight anymore. But luckily, I don't need to. I just need to talk about calculus. So I've spoiled this video a little bit. I'm sorry. I hate spoilers. You probably hate them too. But let's get into some problems. Let's do some more integrals. Integrate? Nope, that's not right. Integrate, part A, the integral of sine squared of x dx. This looks easy. We can't do a u substitution because there's no cosine. Integration by parts. If we took the derivative of sine, we'd get cosine. If we antiderivative sine, we'd get negative cosine. Now integration by parts would lead us in a loop. There might be some tricks that we can use to make it work, but we're not going to. Pythagorean identity is not going to help. 1 minus cosine squared is not a useful integral because then we have cosine squared and we don't know how to integrate that either. So you know what to do because I spoiled it for you. Power reduction formula. And you might be like, Jason, I don't remember a power reduction formula. That's fine. You know who does remember? F documents classes SPSCC Math 142 identities.pdf remembers. That's not so catchy. Power reducing. The sine squared of any angle is 1 minus cosine of double that angle over 2. The power reducing formulas, which can also be used as half angle formulas, are really just the double angle formula for cosine moved around. But anyway, all of these identities relate to each other. If you want to learn more about that, why don't you take Math 142, Precalc 2. I've got tons of videos on them if you want. Honestly, it could be a good refresher, but you don't need to. So this tells us that sine squared is 1 minus cosine of double that angle over 2. And just like that, this integral went from 2. Good. So that is our next method. Sometimes we'll use power reducing formulas. And we do that when there's kind of two cases that are sort of different, sort of the same. Is if we have just sine or cosine to any exponent, or if we have even exponents for both. So sine to the 2j, cosine to the 2k, because it doesn't have to be the same exponent, dx. So if they're both even, or if there's just only one, then this will work. All right. Wait, does this one need to be even? I think it probably does. Because if this is odd, we get sine cubed, for example. You can use the other method. So let's make this even too. And as an example is literally, oh no, not what we're doing. Sine squared. Great, what we're doing. I introduced the case early. I didn't wait. I was too excited. I couldn't slow down. So we use the power reduction formula. And now what do we have? The integral of a half, that's easy. Minus 1/2, integral of cosine of 2x. Well, that's easy. That's just a u substitution. Specifically, it's a u substitution that we've done so frequently. A lot of times we kind of skip the step, but it's good to do a u substitution for that integral. The antiderivative will be 1/2 x minus 1/4. Antiderivative of cosine is sine. Plus c. And again, you take the derivative of this, you should get this because of the chain rule. So that's what we've got. Oh, we're done. Nice. Voila. Nothing to it. Part B. Integral of cosine to the 8th x, sine to the 5th x. So this video is not just for power reducing formulas. I want you to think of all the methods. I want these videos to be iterative. Cumulative is the better word here. Because this is not case 3, right? Cosine to the 8th, sine to the 5th. That's one even and one odd. These are just for evens. Power reducing formulas are for evens. Okay. It's not this. One even, one odd. Oh, that's Pythagorean identity into U substitutions. That's what we're going to do here. Which one do we Pythagorean identity? The odd one. Because remember, we need a leftover for a U sub. So we're going to Pythagorean identity sine to the 5th. How? By writing it like this. So I did a lot there. But you should believe me when I say that these red things are the same. Sine squared squared times sine is sine to the 5th. We write it this way so that we can use the Pythagorean identity on sine squared. So when we do that, easy peasy, we get 1 minus cosine squared of x squared. And now, hey, look, we've got a bunch of stuff with cosines multiplied by the derivative of cosine, missing a negative. A U substitution will come in and save the day. So we say let U be cosine of x. Why? Every U substitution I've done has been with cosine, not sine. Du is going to be negative sine of x dx. So we add a negative, and then everything in blue is our du. We're left with negative. Blue is du. What are we left? What's the leftover? What doesn't have an underline? That's going to be cosine to the 8th times 1 minus u squared squared. Now don't panic. It's just some algebra. We don't have to do any fancy calculus methods here. We don't have to do a W substitution, which works both ways. The letter W or a second U substitution. We just FOIL this out and simplify. We get the integral of u to the 8th. This becomes 1 minus 2u squared plus u to the 4th. And then we distribute, which I'll do on the next page. Don't forget that negative in front. When we distribute, we get u to the 8th minus 2u to the 10th plus u to the 12th. And we use the power rule a bunch. 1/9 u to the 9th minus 2/11 u to the 11th plus 1/13 u to the 13th plus c. We distribute and replace back with x's. U is cosine. Remember to distribute, Jason. Distribute that negative. And we get this beautiful, beautiful result. Checking our answers, very possible here. It would be a very good idea, especially if you were worried about missing negatives. And then you will have to, again, use some identities to get back to what we started with. But who knew this integral would have a 1/13 cosine to the 13th? Not me. Well, I didn't know. I haven't done enough of these problems to know what the answer is going to be. I don't know what these answers are. We discover them together. Although I choose them for specific reasons. Okay, so part C. Integral of sine squared of x, cosine squared of x. Have we covered this? A U sub won't work because we need a single cosine or a single sine. We don't have that. Pythagorean identity, maybe. But again, we won't be able to do a U sub like that. What does our chart say? Our chart says if we have the integral of sines and cosines with even exponents, we need to use power reducing formulas. So let's do that. There's a power reducing formula for sine, power reducing formula for cosine. It's almost the same formula, just one's a plus, one's a minus. Also, if you want to, you can, you can maybe rewrite this to make it a little bit easier. Whoa, why am I scrolling while I'm writing? That can't be intended, Firefox. I don't usually use Firefox for this. Oh, I don't like this. What is happening? Okay, you could split this up into two, because that's what we're always going to do every time. That worked better in my head. All right. So sine squared is going to be 1/2 minus 1/2 sine of 2x. Cosine squared is going to be 1/2 plus 1/2. Whoa, cosine of 2x. And we still have the dx. Again, these are equivalent to 1/2 minus cosine of 2x over 2. So we can just write them this way. Makes it a little easier. And then we have to distribute. Once we distribute, something's going to happen. You can do this integral. I recommend pausing the video. Try to do this out. See what you get. It's not that dastardly of a surprise. But if we FOIL, what do we get? 1/2 times 1/2 is 1/4. And then, ooh, look at this. This is the difference of squares. How nice. So the middle terms are going to cancel. You could write them out and cancel them, or recognize that it's the difference of squares. Cosine squared of 2x, like so. Now this first part, super easy to integrate. The second part, we have a cosine squared. We do the cosine squared integral the same way that we do the sine squared integral. With the power reducing formula. We get to reduce the power again. Wow. How fun. So you could integrate the first part. I'm going to leave it alone. Cosine squared is 1/2 plus 1/2 cosine of double that angle. Don't put 2x here. It's double the angle when you reduce it. Right? We have a u, and when we use the formula, it becomes a 2u. The u in this case, not the same kind of u as a u sub, but the idea is the same, right? If that's u, this needs to be 2u. When we use that formula. Now we clean things up and we've done all the hard part. Distribute that 1/4, we get 1/4 minus 1/8. Distribute the negative 1/4 minus 1/8 cosine of 4x. And again, 1/4 minus 1/8, that's 2/8 minus 1/8, that's 1/8. So this, we can anti-differentiate. We get 1/8 x. Oh, we're in a different color now. Antiderivative of cosine is sine. But because of the chain rule, we're going to have to compensate for that and divide by 4. And we'll be back to our regular color and get... Oh, wait, we're already done. That's just the answer. Right? There's nothing else to do. Let me check our answer. Let's check our answer for once. This is the end of the video. But if you want to check your answer, you can. You can stick around with me or leave. Bye-bye. When we take the derivative, we're going to get 1/8 minus 1/32. Derivative of sine is cosine. Multiply by the inside. 4/32 is 1/8. So we get 1/8 minus 1/8 cosine of 4x. Oh, checking your answer here is really annoying, actually. So we need to use the double angle formula. This is good trig practice. the cosine of 2 times any angle is equal to, there's a couple of ones, right? We can choose which one we want to use. Doesn't really matter. It kind of matters. Use 2 cosine squared minus 1. All right, so when we use that, I'm switching colors left and right. Cosine of 4x, u is 2x here, becomes 2 cosine squared of 2x minus 1, where again, this is 2u, and this is a single u. And then we simplify this. 1/8 minus 1/4 cosine squared of 2x plus 1/8. So the 1/8 plus 1/8. So checking this answer is really some good trig practice. This is why I actually chose to do it. So now we have 1/4 minus 1/4 cosine squared of 2x, and we have to use that same double angle formula. Cosine of 2x is getting squared. So what's cosine of 2x that's getting squared? Well, it's 1 plus 2 cosine squared of x. No, it's 2 cosine squared of x minus 1. I don't remember the formula apparently. I think I was doing the sine one. Yeah, no, I wasn't. I can't save this. 2 cosine squared minus 1. And cosine of 2x is getting squared, so we have to keep that. Now we square this out. We get 1 minus 4 cosine squared of x plus 4 cosine to the 4th of x. We distribute minus 1/4 plus cosine squared of x minus cosine to the 4th of x. I really hope I haven't made a silly error here somewhere. I think we're okay though. Because remember, we're trying to show and check. This is taking longer than the integral. We want to get back to sine squared, cosine squared. We can factor out a cosine squared of x. Oh, look. That's sine of x squared. Pythagorean identity. So checking your work. Wait a minute. Hey, Jason, wasn't there a section in pre-calc 2 or trigonometry where we had to prove that 2 things were equal to each other? That's what we're doing here. That's how we're checking our work, is that section. It's useful. Whoa, look at that. It's useful to check our answer. If you're just doing calculus problems and you want to check your answer, you can actually stop right here. Now, this is not a proof, but if you're just checking your answer, right? And you're curious, is 1/8 minus 1/8 cosine of 4x? You're curious, is that equal to sine squared of x times cosine squared of x? All right. Desmos wants parentheses here. You're curious, are these 2 things equal to each other? Well, look. Their graphs are equal. This is not a proof. But if you're just checking your answers, if you want trig practice, check it the way I did it. If you just want to know whether you're right on the homework, you can check it this way. I think a lot of the homework questions have the answers, but it's just something to think about. All right. Let me know if you have questions. This video is done. Bye-bye.